In this section, we're working with linear equations. Now, a linear equation is an equation that you can make look like this. AX plus B equals C. Now, in this case, A can be any number. X is always to the first power. You know what? I'll write that. Plus B can be any number, and C can be any number. So for an example, you might have this. 5x plus 6 equals 12, something like that. That's what we've been working with. Now, doesn't matter what the equation starts out with, as long as the exponent on x is 1. There's only one variable, in our case, that we're looking at, and the exponent is always 1. So we've been looking at things that look like this. Say 2x plus 4 minus 3 times 5x minus 8 equals 0, say. Right? It's still linear. It doesn't matter how big this thing is down here. We can work through this and again eventually get it down to look like this here. Something times x plus a number equals c. But the point is that the exponent on the x is 1. Right? So the exponent on x is 1. Now, if it's 1, that means it's linear. If the exponent on x is 2, then it's not linear anymore. Then it's quadratic. So there's different names for these. If it's 3, then it's called cubic. And if it's 4, well, then we just say 4th degree. Right? But we're just working right now with exponents of 1. So linear equations can have one solution. You know what? I'm going to say this. It's not just one. It's exactly one. Exactly one solution. Now, that's what's been happening in all the equations we've solved so far. They've had exactly one solution. Can have exactly one solution or 0 solutions. Right? It's possible that these equations can have no solutions at all, or infinitely many. Solutions. Now, there's nothing in between. You're either going to have one solution, no solutions at all, or infinitely many solutions. Now, I'll give you an example of each one of these. Here's an example of an equation that has exactly one solution. Say we take 3x plus 5, and we say that this is equal to 11. All right, now this is a linear equation. It looks like this, right? ax plus b equals c. So this is a linear equation. It's going to have 1, 0, or infinitely many solutions, and this one here that I've drawn has exactly 1. So let's solve it. So what we'll do here is we will subtract the 5, all right? So we will subtract that 5, so we'll get 3x equals now 11 minus 5 is 6. Now we're going to divide by that 3. And if you divide by 3, we'll get x equals 2. And that is it. That is our one solution. Now this is the only number that works. No other number works at all. If there was another number that was a solution, it would have shown up in our work. Now here's an example of an equation. We'll do several of them actually that have no solutions at all. So the first one, let's keep it really simple and we can see what's happening. What if we have this? X plus 1 equals x plus 2. Now remember, x is just some number. So think of some number, add 1 to it, you get something back. Add 2 to it, you get another number back. They're not the same. There's no way that if you take a number, add 1, and add 2, it can come out to be the same. Now, if you solve this equation, let's just go ahead and solve it. What we're going to do is maybe, I notice I've got x's on both sides. So suppose I'm going to get the x's on the left side. Let's get rid of these. So what we'll do is we'll subtract x. Now, if you subtract that x, you have to do it from both sides. So what do you get? X minus x is 0, so that one's gone. X minus x is 0, that one's gone, and we're left with this. 1 equals 2, and of course, that is false. This is called a contradiction. This equation has no solutions. So I would write no solution to this equation. Here's another example. Suppose you had 3x plus 7 equals, now let's just make something up here, 3 times the quantity x plus 2 minus, say, 12. Now, it's not obvious right away that this equation has no solutions, but let's work through it and see what we get when we solve it. So we'll get 3x plus 7 equals, now multiply through here, right? Distributive property. We'll get 3x plus 6, and then minus 12. So on the left side, we've got 3x plus 7, and on the right side, 3x. Now, 6 minus 12 is minus 6. Now, you can maybe see it right here. You take any number and you triple it, add 7. Well, what if you take that number and triple it and subtract 6? They cannot possibly be the same. Let's just solve it, just to be sure. See what happens when we solve this. Well, you can probably see it already. You've got 3x on this side, 3x on this side. You've got x's on both sides. Choose a side. Doesn't matter. Suppose you choose the left side. Let's get rid of these. So I'll subtract 3x. I think you can see what's going to happen here. If you subtract 3x, well, on the left side, if you subtract 3x, 3x minus 3x is 0. No x is left, and you're left with a 7 equals, and then if you subtract those 3x's on the right side, that's 0, that's gone. The x's are gone, and you're left with negative 6. All right, and 7 equals negative 6. That is a false statement. So what you get here is a contradiction. And whenever you get a contradiction, that means no solution. Okay, or actually, I'll do it over here. Number is solutions. Oh, I don't want to write that. Looks like there's 0 as a solution. So let's just say 0 solutions. The number of solutions is 0. 0 solutions. Now here's an example of a linear equation that has infinitely many solutions. Suppose we do this one. Here's a straightforward one. What if you have this one? X plus 1 equals x plus 1. Now what this says is you just think of some number. Call it x. Think of any number you like. Add 1 to it. What about this one over here? You think of that number, you add 1, don't you get the same thing? These are identical. These are identical. Now, what happens if you try to solve for x? We can probably see what's going to happen right now. But if you solve for x, we're going to subtract x from both sides. And what do you get if you subtract x from both sides? The x's are gone, right? From this side, x minus x is 0, it's gone. X minus x is 0, it's gone. And you end up with 1 equals 1. Now that happens to be true. Now this is called an identity. We've eliminated all the variables and we're left with a true statement. That's an identity. And in this case, there are infinitely many solutions. Any number works. No matter what number you think of, it's going to work. Think of any number, put it in here. Add 1 to it. Put it in here, add 1 to it. You get exactly the same number every time. So everything works. Here's another one that's not so obvious. How about if we try 25x minus 35 equals, now let's write it as 5 times the quantity, 5x plus 4, and then minus 55. Now, this equation has infinitely many solutions, but it's hard to tell looking at it this way. Let's simplify it. Let's take that 5 through and eliminate those parentheses. We'll get 25x minus 35. It's equal to, multiply through, 5 times 5x is 25x. Maybe you can get an idea now. 5 times 4 is 20, minus 55. Now, on the right side, left side is cleaned up. We can't do much there. But over here we can. Let's rewrite it. 25x minus 35 equals 25x. Now, 20 minus 55 is minus 35. Now you can see it, right? The left side and the right side are identical. So since they're identical, we are going to have an identity. Now, if you can see it here, that's fine. If you can see it here, you can go ahead and write identity, which means infinitely, I'll abbreviate, infinitely many solutions. Now, if you don't see it, and you want to carry it further, let's go ahead and solve for x. So I got x's on both sides, 25 of them in fact, so why don't we subtract 25x, all right? So here's the plan. Subtract those 25x's. But if you subtract 25x from the left side, you're left with just negative 35. If you subtract it from the right side, you're left with negative 35. All right, now you can definitely see this as an identity. Infinitely many solutions. But suppose you just wanted to push it further, just for fun. So what if you wanted to get, say, 0 on this side? Something equals 0. So what you're going to do is you're going to add 35. But if you add 35 to both sides, you get 0 equals 0. Okay, now that, again, is a true statement. And a true statement will always give you an identity. An identity means infinitely many solutions. Just to summarize, a linear equation can have exactly one solution, no solution, or infinitely many solutions. So exactly one solution is going to look something like this, right? You maybe have like x equals 4, exactly one solution. No solution, this is called a contradiction. Now a contradiction, you're going to end up with something like this. I'll write a couple. You could have like 3x plus 5 equals 3x minus 4, something like that. Or you could have like x plus 1 equals x plus 2. Or if you even solve it, you might end up with something like this. 1 equals 2 or 0 equals 4, something like that. All right, where you're saying that the left side and the right side are equal when, of course, they're not. That's a contradiction, and you have no solution at all. Or you could have infinitely many solutions. Now, infinitely many solutions, there's a name for this. This is called an identity because the left side and the right side are identical. Now, you might have something that looks like this. You could have, say, 5x plus 2 equals 5x plus 2, as long as both sides are identical. And you might even, like if you tried to solve this, you could get 2 equals 2, or you could even boil it down to 0 equals 0.